Atlas-O-Matic in 5, 4, 3, 2, 1.
Are you tired of being woken up in the middle of the night to rescue your database?
Yes!
Are you sick of scrambling to keep your database healthy as your business grows?
Yes!
Are you plagued by a database that just can't keep up with your workload?
Yes!
Does the thought of keeping your database software up to date and patching your servers without downtime make you panic?
Yes!
Well, me too. But I'm here to tell you that you don't have to take it anymore.
Impossible!
What if I told you there exists a database that can automatically scale up or down to meet your needs?
That's impossible!
What if I told you there exists a database that requires zero downtime for upgrades, patches, and maintenance?
Totally impossible!
Well, the impossible is now possible. Ladies and gentlemen, presenting the Atlas-O-Matic. But before I reveal this spectacular new invention, we must take a moment to reflect on the history of databases and how we got to where we are today. A long, long time ago, well, not that long ago, in 1970, IBM engineer Edgar F. Codd invents the relational database. He starts with a bunch of tables. Ooh, I like the outdoor one. Not those tables, but these tables, the ones that contain a bunch of data. Our friend Edgar creates relationships between those tables to connect the data. Hi, Table A, I'm Table B. Seems like we have an idea in common. Let's join together. This works pretty well for the applications of the time and changes very little year after year, even though people start joining lots more data, and that data gets more and more complex. Nice to meet you, Table B and C and D and E, F, G, H, I, J, K, L, M, N. Oh my goodness! This is insane. And it goes on for nearly 40 years. Fast forward to 2007. Applications are huge. They operate at massive scale. Social media is a thing. Finally, two dudes from New York, Dwight Merriman and Elliot Horowitz, enter the scene and say, "We can no longer relate to this relational thing. Let's build a document database that makes data incredibly easy to work with." MongoDB is born. The entire developer community and civilized world breathed a sigh of relief and said, "Where have you been all my life?" Finally, the data matches how we work with it. Applications can quickly retrieve it and manipulate it without countless layers of expensive translation. Developers are happy, but they are hungry. "We have too much data. We need to cluster the clusters." Sharding is added. Then they shouted, "We need to query deeper and sum things with averages and counts and data upon data upon data." The aggregation pipeline is introduced, until finally, the longtime holdouts spoke up. "Yay real until you got transactions." So, everyone at MongoDB dropped acid. Transaction support, that is, and as MongoDB grew, it became apparent that configuring and maintaining this beautiful database software was not so easy. This is where things get cloudy, but not in a way where it's difficult to see or where you think it's going to rain in a few minutes. I'm talking about cloud computing. Suddenly, infrastructure becomes a service, and we can get what we want when we want it and pay for only what we use. And so came a bunch of database services, but alas, they were all relational. The crowd spoke once again. "I want my MongoDB in the cloud!" And Atlas was born. And, true to MongoDB, you can start for free and pay for just what you need. The developers rejoiced.
Yay!
And that brings us here today, ladies and gentlemen. Today I reveal to you the Atlas-O-Matic. Yes, the Atlas-O-Matic. The one and only self-managing, auto-healing, auto-scaling wonder of the database world. Start small and grow big. Start big and get small. This database does it all.
That's too good to be true!
You've got to see it to believe it. Come on in and take a look. I log into the Atlas console. I can even use a Google account.
Wow!
Imagine we have a new startup. It's a social media network like you've never seen before. I call it Socializer. I know it's going to be big, but how big and how fast we're going to get there, I have no idea. I pick an M10 size cluster. It's the cheapest dedicated cluster out there. Gotta keep the investors happy. But what if this takes off? I'm going to have to monitor all the time. How am I going to do that? I gotta code. I gotta do the books. I'm the CEO, the CTO, the CFO, C3PO. I'm also the lead engineer, the human resources director, and the head of facilities. We work out of my house. What if I run out of disk space? What if I need more compute power?
What are you gonna do?
I thought you'd never ask. I'm gonna turn on storage autoscaling. Without doing a thing. Look, Ma, no hands. As you can see, this is turned on by default when you create your Atlas cluster. Here's what it means. Atlas keeps you from running out of disk space so you don't have to worry about it. When your storage usage exceeds 90% of available disk space, the system scales the disk to maintain 70% capacity. Let's see an example. Start with a 10 gigabyte disk. When we exceed 9 gigabytes of storage used, the disk is scaled to 13 gigabytes, which brings us back below 70% capacity usage. Anytime your storage usage exceeds 90%, Atlas sends you a notification. Then, when disk scaling occurs, you receive an additional notification letting you know the new disk size. As an aside, you can configure notifications to come via text or email. Pro tip! It's time for our first pro tip. You can always see a history of events that occurred in your project by viewing the activity feed. Look for this icon on your Atlas dashboard. Now back to scaling. Our disk expands as our business grows, but look here, we've reached the max storage for our instance size. Uh-oh! Do I panic?
No!
Of course not. Atlas scales to the next cluster size. The system continues to scale the cluster size until we reach the max available disk size of 4 terabytes, which occurs at an M50 cluster. After that, it's time to shard, but we'll save that for our next episode. So, we no longer have to worry about disk space, but now what happens if...
We need more power!
Right, let's talk about compute power. Socializer is really taking off. The amount of concurrent users is growing every day and putting high load on my database. So, why am I sitting on the beach sipping a nice cold drink?
What is your secret?
I'll tell you what my secret is. I turned on compute autoscaling. Ooh. Let's go back to the cluster configuration. Head to the autoscale section and check cluster tier. Next, head south and check allow cluster to be scaled down. I like to enable downscaling to save cost in the event our usage declines, even though Socializer is currently growing like crazy. Notice that we can set minimum and maximum cluster sizes. These are very important. The minimum cluster size indicates the smallest size I will allow my cluster to scale down to. This ensures that I always have a baseline level of compute power and will never go lower. The maximum cluster size indicates the largest size I will allow my cluster to scale up to. This lets me ensure that the costs don't exceed my expectations and limits.
Wow!
I know, it's powered by magic. Okay, not really, but it feels like it. Here's the inside scoop. Anyone else craving ice cream? Behind the scenes, Atlas is constantly monitoring the CPU and memory usage for your cluster. Remember, all clusters have at least 3 servers. As a result, we calculate the average CPU and memory consumption across all of the servers in that cluster. Can I get a drum roll, please? When CPU or memory use exceeds 75% for 1 hour, we scale up to the next instance size until we reach the limit set in our configuration. When CPU and memory use is below 50% for 72 hours, we scale down to the previous instance size, but not below the minimum set in our configuration. Watch the fine print! The fine print, of course. Please take note. Atlas will not scale your cluster if the op log is below 90% full and does not contain a large enough window to handle the time it takes to fully resync a node if necessary. Atlas will adjust your max instance size for compute autoscaling should storage autoscaling push the instance size above the designated maximum. Atlas will adjust your min instance size for compute autoscaling should storage on your cluster exceed the maximum allowed storage on your specified minimum instance size. Note that you cannot currently customize the scaling criteria, but you may be able to in the future. This product may cause excessive happiness and sudden bursts of innovation, resulting from you being freed from the stress of managing your database. Please enjoy responsibly.
Extra, extra.
Did you hear that? Did you see the news? Socializer's gone global. Now we really can't afford any downtime. We can't take any outages for
Upgrades, patches, or maintenance.
You know what that means. I am up all night taking bubble baths.
How is that possible?
Remember what I told you. Atlas requires zero downtime for upgrades, patches, and maintenance. Look, Ma, still no hands. Allow me to explain. All clusters in Atlas have a minimum of 3 nodes per replica set, a primary and 2 secondaries. This means that we can take a single server down at a time and retain high availability. Atlas performs maintenance in a rolling fashion, 1 node at a time. Let's see it in action. Shut down secondary node 1. Apply updates to node 1. Restart node 1. Then shut down secondary node 2. Apply updates to node 2 and restart node 2. Finally, shut down primary node 0. The primary moves to node 1. Then apply updates to node 0 and restart node 0. Mission accomplished. Pro tip. It's time for another pro tip. Configure your driver and application to handle failover when an election occurs and moves the primary from one node to another. Test in Atlas by selecting Test Failover.
Yay!
Hey, wait a minute. What if I need more control over when these rolling restarts occur? Never fear, my friend. You can set a custom maintenance window for your Atlas project. In addition to this lovely wood trim, with a maintenance window enabled, you get a notification 48 to 72 hours prior to the start of maintenance operations, the option to defer maintenance for 1 week, and the option to start maintenance immediately outside of your designated window. Note that critical security patches always get rolled out immediately. Safety first. Well, sign me up. I'm a believer. Let's get to it then. Visit mongodb.com and click Start Free. And that, my friends, is the one and only Atlas-O-Matic. Welcome to the era of the hands-free database. Now go do the impossible. I know you can. It's time for some demos. Launching a cluster. I created an organization named Socializer Enterprises. Inside of that organization, I created a project named Socializer. Now, let's take a look at how we create the cluster I talked about earlier. From the main display, click Build a Cluster. You are presented with 3 options. The option on the left is for our shared tier clusters. These are intended for teams learning MongoDB or developing small applications. This includes our Free for Life offering. In the middle, we have dedicated clusters. These are for teams building applications that need advanced development and production-ready environments. These clusters have autoscaling support. And on the right, we have dedicated multi-region clusters. These are intended for teams developing world-class applications that require multi-region resiliency or ultra-low latency. For Socializer, I start with a dedicated cluster. Next, I choose a cloud provider. I'll go with AWS for now. After that, I need to pick a region. Let's go with US East 1. I select the smallest dedicated instance size of M10. As you saw earlier, autoscaling for storage is turned on by default. Let's also enable compute autoscaling. I enable downscaling, set the minimum to M10, and then set the maximum to M80. I want to highlight an additional autoscaling behavior. Let's navigate to an M40 cluster. Watch as I increase the disk size to a size greater than the max supported disk size of our minimum instance size of M10, which is 120 gigabytes. As you can see, the minimum instance size is adjusted to the next size up that supports my current disk size. It is also worth noting that if your oplog size is less than 5% of the new disk size, it is automatically scaled to reach 5% of that new disk size up to a maximum of 50 gigabytes. This helps to prevent servers from falling off the oplog during maintenance and upgrade operations. Now, let's choose our MongoDB version. I set it to 4.2. I also enable backups. The backup system leverages cloud provider snapshots. This is a fast, efficient, and cost-effective way to back up our data. I'm also going to enable point-in-time restores, which allow me to restore back to any point in time within the window configured in our backup policy. I name my cluster Socializer and click Create Cluster. In just a few minutes, our cluster will be live and ready for use. Advanced Cluster Configuration. Let's quickly talk about growth. As your application grows, you may explore distributing your cluster across multiple cloud provider regions. You can do so by adding electable or read-only nodes into any number of regions. To do that, we edit our cluster configuration and flip the switch for multi-region workload isolation and replication options. I add a few additional electable nodes to US West 1 in Northern California. By adding electable nodes to an additional region, the primary for your replica set can move to that region if one cannot be elected in the highest priority region, which is US East 1 in our case. Notice that I must maintain an odd number of nodes in the cluster. This ensures that we can always appropriately direct writes in the event of a network split. You can also choose to add non-electable, read-only secondary nodes. Since these are not electable, they do not factor into the odd node count check. And finally, you can add non-electable, read-only analytics nodes to your cluster. These nodes provide you with the ability to isolate your analytics queries and operations to specific nodes in the cluster without impacting the health and performance of the cluster. Now, let's quickly talk about sharding. With Atlas, sharding is a method for distributing data across multiple machines. We use sharding when our dataset grows very large or requires high throughput operations. With Atlas, we can scale in two ways, vertically or horizontally. As you saw with storage and compute autoscaling, we can increase our instance size to gain more capacity. However, when our workload exceeds the compute capability and data size of our largest instance, we need to add additional replica sets and distribute the load. This is achieved through sharding. To enable sharding in Atlas, simply flip the switch and select the number of shards that you want. You can increase or decrease this number at any time. When enabling this feature, be sure to choose a proper shard key, such that the data and load will be evenly distributed across all of the replica sets. Now, you may recall that our Socializer app really took off and we went global. If this were a real-world app, you can imagine we would need to deal with a high number of read and write operations occurring across the globe. In addition, we might encounter data sovereignty issues where data that originates in a country must reside on servers in that country. This would be seemingly difficult to set up, but Atlas makes it really simple. Click Global Cluster Configuration. Select the appropriate performance template. Review the changes. Apply the changes, and then sit back and relax. Performance. I now want to talk about performance. I have already shown how autoscaling lets you take a more hands-off approach to managing your cluster. One very important aspect of database management, not to be overlooked, is optimizing performance. It is very easy for a missing index to cause heavy CPU and memory load on your cluster. It can even trigger compute autoscaling to move you to a larger, more expensive instance size when all that is needed is an index. Fortunately, Atlas is constantly monitoring query activity in the background and can make suggestions on how to optimize your dataset for maximum performance. Here is a quick glance into the Performance Advisor. You see here that the system detected a missing index on my foo collection. The Performance Advisor alerts me to this scenario and allows me to resolve the issue with a few clicks. I'm going to click Review and then Confirm. Next, I want to talk briefly about disk IOPS. For those of you that are not familiar with the term, it stands for Input-Output Operations per Second. The disk volumes for your Atlas cluster have a basic number of IOPS relative to your cluster's disk size. However, workloads that have a high frequency of concurrent reads and writes may benefit from using provisioned IOPS where you can specify the desired number. Using the metrics view, analyze the disk IOPS for your cluster. If you are consistently running up against the max read or write IOPS for your volume, consider enabling provisioned IOPS and adjusting the number accordingly. Doing so is simple. Navigate back over to the cluster editor, edit your cluster configuration, choose Provision IOPS, and slide to the desired value. Click Review Changes, and then Apply. Advanced Security. Last but certainly not least, Atlas provides an array of enterprise security features to protect your data. You can use Active Directory via LDAP-S for secure single sign-on support. You can encrypt data using your own encryption key via AWS KMS, Azure Key Vault, or Google Cloud KMS. This means that when you revoke your encryption key, your cluster will automatically shut down and alert you within 15 minutes, giving you the ultimate level of protection and control. Enable database auditing to provide detailed monitoring of any database activity that you desire. Ladies and gentlemen, this concludes our presentation of the Atlas-O-Matic. Thank you for your time today.